Hello, welcome to the Designing Best Practices in Architecting a Data to Insight Solution on AWS session. Today, I'll be talking about the AWS Analytical Platform and how you can use some of the best practices to design a very scalable big data architecture. We'll also go through evolution of business intelligence and how it means for the business when they're innovating and when they are bringing new strategies to make good use of their data. We'll also talk about our lakehouse approach, scalable architectural design patterns, and how to build analytics and BI pipeline in your organization. We'll be sharing a lot of new best practices to make it more effective and streamline in your organization. So let's get started with the AWS Analytical Platform. So we have purpose-built analytics solutions. Just like we have purpose-built databases, we have purpose-built analytics for all the different verticals in a data pipeline. For example, for data ingestion, we have services like Amazon Kinesis, data streams, or Amazon Airflow, which now allows you to do batch processing for data which is stored in different SaaS applications. We have Amazon managed streaming service for Kafka to do real-time ingestion for IoT streaming. For batch processing, we have recently introduced something called AWS Glue, which is our service to provide data scientists and analysts a way to quickly analyze the data and do some correlation analysis. We have heard from the customers that data processing is sometimes difficult and requires a lot of development expertise. With services in Data Brew, we now allow you to easily mash up your data, analyze, and correlate different features to build a model that could be used to formally create a data pipeline. So as you can see, we have purposeful services for all the different aspects of building a data pipeline. And these services are geared towards a specific personas. So you can see for data analytics, we have Athena, Redshift, which is our data warehouse, and it allows you to do petabyte scale data processing, and it could be used by data modelers, data scientists, and business analysts. So today I'll talk about all the different ways you can build and optimize your data pipeline. So let's get going. Before I get to the design patterns, let's talk about business intelligence and how the business intelligence has evolved and what are some of the new patterns that you can use to improve your business intelligence operational pipelines. So let's start with the approaches that have been commonly adopted in the enterprises. Historically, the business intelligence was largely set up by corporate IT. It was an approach called top-down BI, where the corporate IT would set up a reporting environment that analysts or business users could consume. It did not go very well because while they provided all the different reports, business wanted to do more. They wanted the flexibility so they can do ad hoc analysis. And what happened, business users started to download the data in things like Excel, and IT started to lose control. Like data would go in a spreadsheet and left in a laptop, which created a huge security and threat vector. So to solve this problem, the bottom-up BI became very popular, and vendors started to build tools for bottom-up BI. But with the bottom-up BI approach, even though it provided all the flexibility and freedom, there were some challenges with that as well. So is there a silver bullet to solve this? Is there a way we can address both the unique features of the top-down BI approach and a bottom-up BI approach so business can get the needed freedom and IT can enforce the controls that organizations require. In our opinion, we feel that an ideal BI tool should harmonize both methodologies and be able to support corporate IT and business together. This is where we released a tool called Amazon QuickSight that allows you to build a business intelligence or a consumption layer to support both the corporate BI and the self-service BI capabilities. It's designed to be serverless, so if you have 100 users or 100,000 users, doesn't matter. The system is fully designed to be true serverless and allow you to scale automatically. It also provides IT admin the services to enforce governance and proper control, so there are no data leakage issues out there. You can also use advanced analytics and machine learning capabilities to deliver insights directly to your business users. You can also enable embedding that allows you to make your applications intelligent by embedding rich visuals and dashboards directly in your applications. You never have to let your users go to another tool to view the insight. They can consume the analytics and visuals in the applications that they live on a daily basis. All right, let's discuss our lakehouse approach. Now we are moving towards our analytics capability. So let's talk about how organizations have consumed analytics. Historically, data warehouse has been the center for all the analytical needs of an organization. Data in the warehouse is stored by ingesting from different transactional store. Data would be transformed first into a star schema, and it's loaded into the data warehouse. That's where analyst and other business user will consume the data. With the growth in big data and with high volume, high velocity type data coming in, it wasn't easy to store everything in a warehouse. So data would store in some sort of lake or a storage layer first. What customers did was, once the data was loaded in the lake, it was then transformed from the raw state and then moved up in the lake or in the data warehouse for easy access. The question now is, with the exponential growth in data, how much data can you move up in the warehouse? So the approach that we have taken is that rather than having to move all the prepared data up at the data warehouse level, you can query the data directly in the storage layer. So Amazon Redshift allows you to query the business data, which is stored in the data warehouse, and the event data in the lake simultaneously, which makes data movement minimal. And that's how we allow unlimited scalability to capture insights about your data. Let's get into the second benefit. We've heard from the customers that once they build the data lake, most of the data lake often becomes data swarms because there's no organization to the data. So it becomes a dumping ground, and it is really difficult to manage them. So what if there is a system to create an organized layer on top of that? What if you can build a table structure that you can easily query? And on top of that, if you can enforce governance, like who has access to that table structure or schema, then you can enforce security with it. So with AWS Lake Formation and AWS Glue, we can address those challenges. You can enforce fine-grained security through AWS Lake Formation to enforce column-level security for the data which is sitting in the lake. If you take a look, These three things, the storage, the catalog through AWS Glue, and AWS Lake Formation, you can make the data lake act like a big, gigantic database, which can really help organizations address the exponential growth of data that they are seeing. On top of this, we have also heard from customers that often there's a need to share data or analyze data which is stored in different data marts or data warehouses. This is often very difficult. And if someone in, say, marketing organization tries to access the data in sales, they often have to move the data from sales over to the marketing warehouse. Only then they can stitch the data together and analyze. What if there is a way that you do not require any data movement or data copy? Redshift allows you to do that. Redshift data sharing capability allows you to build a query with the data in your source warehouse and cross-joining the data which is in another warehouse. Also, we allow you to access other operational data source, which also minimizes data movement. It also allows you to do real-time analytics for data which is stored in other warehouses or operational data stores. Similar to this, if you want to analyze data which is stored externally, say in on-premise environment or some other lake, or on any other cloud platform, you can still query that. So Redshift with other AWS analytical service enable you to have a scalable lakehouse approach without having to move a lot of data. That's our approach. Now, the second approach is if you have a data lake built on Hadoop or Spark, that's also a viable scenario. What we offer is a separation between compute and storage. So rather than you having to store all your data in an HDFS layer, you can store this data in S3, which is much cheaper and cost effective. With that benefit, you can address the scalability challenge that you may run into. Now, what we also offer is a centralized metadata store. So rather than having to use a catalog which is available with your Hadoop environment, you can use a centralized catalog, a separate catalog layer that enables you to access data which is not just stored in your SDFS layer, but also is stored elsewhere. It allows you to break the data silos that organizations have historically struggled with. A common scenario that you can use, or a pattern that you can use, is having different compute or analytical layers on top of this environment. Like you can have Spark on EMR, you can use a lakehouse with Redshift, or you can use a Presto on EMR. Okay, and you can also enable real-time analytics by querying data with transactional stores or NoSQL stores like DynamoDB, or you can query other external sources as well. So this allows you to have a very extensible lakehouse approach without having to move a lot of data. So what is our design principle? Our design principle is in-place analytics with minimal data movement. So remember that. Let's talk about a few scalable architectural design patterns using our minimal data movement approach. The first one is lakehouse architecture using Amazon Redshift. So we talked about the scalable model. Here, we can have prepared data from CRM and operational stores loaded in Redshift, and event data or other raw data stored in the lake. We can query the data in the lake and the operational stores from Redshift through a feature called Amazon Redshift Spectrum. Analysts can run big data query or large-scale data queries directly from Redshift, querying both the data in the lake as well as data in Redshift. So you don't have to worry about querying data in the lake separately. Everything could be done through one system. The data sets or the visual layer can be created in QuickSight or any other BI tool. Using QuickSight, you can store the results in a cache called Spice, so you don't have to do subsequent calls to the Redshift every time the visuals are refreshed. So Spice provides you a cache layer, so you don't have to go back to Redshift to process the query again. You can still run direct query using materialized views to improve performance. Next design pattern is using ad hoc analysis using Amazon Athena. So similar to the previous design, you can use Amazon Athena as an ad hoc analysis tool. If you do not want to use a data warehouse and your entire prepared layer or prepared data is stored in the lake, what you can do is you can use AWS Glue data catalog to create a metadata layer. This metadata layer is created using AWS Glue Clara. Once this metadata layer is created, then you can use Amazon Athena to query it. You can also use AWS Lake Formation to set up security or fine-grained access. Where this helps is if you want to lock down a user or an author to only certain tables in the data or only certain columns in the table, then you can lock it down. Previously, this was difficult, and and column level security needs to be enforced at the application level. Now you can enforce column level security directly at the lake, which simplifies and improves the governance for your lake. The third design pattern is using a combination of Amazon Athena and Amazon Redshift. This is a common pattern that we see. Amazon Redshift, if you have data setting in Redshift and you want to query it, that's an option. So typically that we see is an analyst would query Redshift for the business data and then use ad hoc analysis for data stored in the lake. And once those data sets are created in QuickSight, the analyst can combine them together to create another mashed up data set that could be used for the visualization. So this is another common pattern that we have seen. And this is what allows you to perform ad hoc analysis and controlled analysis in your environment. The third design pattern is using big data analysis using Spark on EMR. That's also a common pattern that we recommend. Here, if your data is stored in the lake, you can have a Spark do the processing, cleaning, enrichment, normalization. All that is stored in the lake and then query through the Spark engine. You can have a Spark use the Hive meta store or the Spark meta store or the catalog as well. And data could be stored in Spice or directly queried in Spark for analytics. Let's talk about a real-time visualization use case. This is another common pattern or request we get from the customer that as soon as my data is loaded in S3 or data is updated in Lake, I want to see that directly in my dashboard. So the system should automatically do all this processing and make it available in my visualization layer. So almost like a real-time visualization. So this is possible. We can set up a process through event triggers in Amazon S3 to do a whole workflow to process the newly uploaded file or the data and then update it in Amazon QuickSight. So the flow diagram here shows that the data is uploaded in S3. It triggers AWS Lambda function. The Lambda function updates the data catalog, and it triggers a glue processing job. So the glue processing job will do the data query, and it ingests the data and loads it into Redshift and also stored in the data lake. The glue job also pushes the logs and notifications to the CloudWatch. And once the data is landed in Redshift, if you have Amazon QuickSight configured to do a direct query in Redshift, then data would be available right away. If you're using Spice as the cache layer, then we can have another AWS Lambda trigger to call an API in QuickSight to do the ingestion. And that way, the ingestion will refresh the data set in QuickSight, and the newly uploaded data would be reflected in QuickSight. Let's now talk about analytics and BI pipeline best practices. Often we have heard from the customers is that they want to understand how to build operational pipeline for different personas. For example, they have data scientists, they have data curators, data engineers, developers, business analysts. How to build different pipeline and security for different personas. So what we have done is we have built our tools to address specific persona requirements and use those to build the operational pipeline. For example, once your data is ingested in S3, you want to grant different permissions for your data curators and data scientists. Now, data curators and data scientists would like to analyze the data which is stored. They want to combine data from different sources. They want to mash it up. And once that processing is complete, they want to hand it off to a data engineer to create a formal data pipeline. For them to do this, they need some ad hoc tools. Now, some data curators are not developers, so it's not easy for them to write code. They understand SQL a lot better, and they are happy to use basic visual tools. So we have provided or just released a tool, AWS Glue Data Brew, that allows curator and data scientists to process the data, enrich it, prepare it, clean it out, and then if there is any transformation needed, they can also do that. Once that transformation is done, then they can hand it over to a data engineer to create a formal pipeline in AWS Glue. They can also use Amazon Athena to do some ad hoc analysis as well. So if they want to query S3 data or operational data without having to go through a warehouse, they can do that. So that's the ad hoc processing tailored directly for data curator and data scientist need. Now, the batch data processing is all about creating formal data processing pipeline. This is where data engineers and developers create batch jobs to operationalize a whole data processing. This could be done through our AWS Glue platform, and Glue Data Brew can also be used here. Going into the data analytics, this is largely used by data analysts or business analysts. They like to run queries based on SQL to analyze the data, and this is the platform where you can easily query data in the warehouse as well as data in the lake. And then the visualization layer is largely used by business analysts and curators. They often do not want to do a lot of data modeling. What they want is a prepared data layer given to them, and they can use that to create visuals. Admins can enforce security, and developers can use this to embed visuals in another application. This is another common pattern that we have seen, that developers do not want to or spend time to create charts and data processing. They want to focus on the business functions rather than building a whole data processing layer. So this framework that we have provided enables that. A lot of ISPs are now using this because it improves their agility and time to market, introduces time to market of their application. Let's now talk about operational pipeline in QuickSight that you can build. Earlier, I talked about that QuickSight is a tool that combines or provide features both for corporate BI as well as self-service BI. This operational pipeline explains how this works. Say you have a user who is an admin, wants to configure an environment for the business analyst and the data curators. The data curators are people who are allowed to clean the data, mash it up, but then they are not allowed to create the visuals. The visuals are created by the business analyst. So you can create a fine-grained or permission control for different personas. This could also be applicable in scenarios when you have dev, test, and prod environment. Say you have a business analyst who is given access to create visuals in a dev environment. This is that scenario. Say you have data sitting in the lake or operational stores. An admin would create a catalog and lock it down with lake formation. This is then given access to a data curator in Amazon who is building the data set using Amazon Athena in QuickSight. This person, this data curator, now only has access to limited set of data, even limited columns. Once this data set is created by the data curator, this person can now share it out to a business analyst or push it out to another environment for QA. Once this data set is created and shared out with a folder, then the business analyst can pick it up, and business analyst can use this data set to create an analysis. Once this analysis is created, it can again be shared out with the team to analyze. Now, business analyst is not required to publish, is not allowed to publish the dashboard. So dashboard publishing now happens through an admin. So you can see different roles are granted different permission. And this way you can manage the entire BI pipeline. And finally, when the dashboards are published, then admins can also embed or allow developers to use the embedding feature in QuickSight to embed this within the application. So different personas, different permissions, and all this could be granted all in QuickSight. Last, I just want to quickly talk about some best practices around cost optimization. So we have Amazon Redshift. You can use reserve instances. We have concurrency scaling feature, is Spectrum to determine the best cluster size and the pricing. We have guidance available that you can use to optimize cost. Amazon EMR, you can use a combination of RI, spot, and on-demand instances to reduce the cost. Commonly, we get asked, how do we optimize cost for Amazon Athena? Because it's based on the amount of data and the number of queries you run. So you can, if you're using QuickSight, you can use Spice to reduce the number of Athena queries. The Athena query could be stored in a Spice, and that will be used to build different visuals, or whenever a visual is refreshed, it will pull the data from a Spice rather than making an Athena query call. File formats, fewer scans means less cost, so we recommend using compressed and columnar file storage in Amazon S3. That reduces the cost. And then Amazon S3 Smart Partitioning reduces the scan, so that's another feature. So with that, we are coming close to the end of this presentation. Hope this was helpful. We will be releasing a lot more new features around the scalability and the lakehouse vision that we have. And feel free to look into our blogs and new updates coming out. Thank you.